Alright, so in this video we're going to talk about derivatives of e to the x, the exponential function e to the x, and a to the x. So let's consider the graph of e to the x and the slopes. So consider the slopes of f of x equals e to the x. So we'll start with the slope at 1 here. If you draw a little tangent line, the rise over run, it's like 4 little boxes over 4 little boxes, is 1. So f prime of 0 equals 1. You'll notice that the function also outputs 1 at 0. This height is 1. So f of 0 is 1. Okay, so now let's look at the slope at 1. So if we look at the slope here, you go over 1, you go up about 3, a little less than 3, let's say 2.7. So the slope at 1 is 2.7. You'll notice that the height here is also around 2.7. So f of 1 is approximately 2.7. These are all approximately's here, so I should be doing little squiggly equals. Okay, and then we'll look at -1 here. So -1, let's draw a tangent line here. So if we do rise over run here, we'll get 2 and 2 over 5. So f prime of -1 is approximately 2/5 or 0.4. And the height here is also 0.4. So f of -1 is approximately 0.4. All right, so let's make a claim. The derivative of this function equals the function. The slopes equal the function outputs. And this function is e to the x. So the derivative of e to the x is e to the x is what we're claiming here. We claim the derivative of e to the x is e to the x. All right, so let's go about proving this claim. Okay, so we'll start with a relationship between e and the natural log. So the natural log of e to the x is x. You could think of the natural log and e as being inverse functions, so they're canceling each other. This is just a true statement. And now I'm going to differentiate both sides. So that take the derivative of natural log of e to the x and the derivative of x. Now I know the derivative of the natural log. We saw that earlier. The derivative of the natural log is 1 over x. So when I differentiate this natural log of e to the x, I'm going to get a train rule type situation. I'm going to have 1 over the inside function, e to the x, times the derivative of the inside function. This is the derivative of the natural log, which is 1 over. E to the x is the inside, so that stays the same. And then we multiply by the derivative of e to the x. And the right-hand side, the derivative of x is just 1. We don't know the derivative of e to the x. That's what we're trying to find. So what I'm going to do is I'm going to isolate this derivative by multiplying both sides by e to the x. And now I have that the derivative of e to the x equals e to the x. And my proof's done. All right, so now I want to consider the function a to the x. Call it g. A to the x. So a is a general base. It's some positive number. Okay, I want to figure out this derivative using what I just learned, which is that the derivative of e to the x is e to the x. So what I'm going to do is I'm going to take this a to the x and I'm going to rewrite it in terms of e. And the way that I do that is I introduce an e and a natural log. Because e and natural log are inverse functions, this is true. And now I'm going to use a property of logs. I'm going to bring the power down. And now I'm going to differentiate. So I'm going to take the derivative of both sides. The derivative of a to the x we don't know, but we can differentiate this right-hand side because it involves e to the x, and we just figured out the derivative of e to the x. The derivative of e to the x is e to the x. Okay, so chain rule applies here. The derivative of e to the x is e to the x. We do need to take the derivative of the inside function. And the derivative of x is just 1, so we'll be left with just natural log of a. Natural log of a is a constant with respect to x, so it just sticks around and the x becomes 1. All right, so now we can take that x back up to a power and make the e and the natural log cancel, and we'll have a to the x natural log of a. So here's our new rule. The derivative of a to the x is a to the x natural log of a. And I'll just remind you of the rule from earlier so you have it in one place. The derivative of e to the x is e to the x. So those are our two rules.